Good morning.
Good morning,
Good
Mr.
morning.
Strong.
How's everyone? Okay. All right, so did anybody do anything amazing over the weekend? Come on, somebody did something.
I played in a volleyball tournament.
Oh yeah? How'd you do?
We got second
Out of 2 teams or how many teams?
out of like 17 teams.
17? What?
Yeah, it was an all-day tournament. It sucked.
Wow, that's very amazing. That's awesome. All right, anybody else?
Disney Plus.
Oh, yeah?
Disney Plus and chill.
Yeah, we still need to watch The Mandalorian. I'm still waiting for that. I've heard that's amazing. So did you watch anything amazing on it yet?
Me, not really. I've
Yeah.
been waiting for my family.
Okay. All right. Well, fair enough. Fair enough. All right. Anybody else? Let's see. We got everybody in Joseph City. Everybody in Holbrook. Looks like everybody's there.
Caitlin's not here.
Who?
Caitlin?
Caitlin. Okay. Thank you. All right. Well, so do you guys know what accreditation is? Can anyone tell me what accreditation is for a school or a college? Well, basically, it's like the school getting evaluated. And so anyway, MPC, every colleges, I'm not sure about high schools, but like usually about every 10 years. And so the higher up you go, like MPC's accreditation is much more difficult than like a high school. And so they have, people come in and evaluate everything as part of the program. Anyway, so MPC has been preparing for accreditation for a couple of years. And so it's today and tomorrow. And so I just came out of a meeting. That's why I was kind of running a little bit late. And so they had this forum. Anyway, they're doing different meetings over the next couple of days. And somebody made mention of MPC's, they have the Eagle Club. And the guy is like, did you say the Evil Club? That's what he thought it was called, the Evil Club. And so I told Dr. Henderson after the meeting that I was going to introduce him as the faculty sponsor for the Evil Club. Anyway, if you have Dr. Henderson, you might appreciate that he thought that was funny. So anyway, okay. Let's see. I think we were right here on practice 1B on finding the rational zeros on 4.3. So our goal is to get through 4.3 and maybe some into 4.4 today. So this week I know is going to be a little different. I know Thursday I'm going to probably post like a video clip or something. I'll give you some more information, but I'm probably going to have you watch a short video on Thursday, but we're not going to have a broadcast on Thursday, okay? So I know that for sure. The rest of things I'm not quite sure, but I do know we're not going to have a broadcast on Thursday. And but we'll have some video clip or something to watch. So I'll give you more information on that tomorrow. Okay. All right. Well, let's go ahead and get into this. We had got to this point in the rational zero test. So remember, with the rational zero test, you start with the factors of the constant, so of 30, divided by the factors of the leading coefficient, 1 and 2. And so then you write down all plus and minus, and then parentheses, and then all of those. And if you have any repeats, like 30 over 2 is 15, and we already have 15, you don't list the repeats. Okay? All right, so we've got to there, so we were actually going to try to find the actual zeros. Okay, so kind of where I go from there is to put the function in the calculator. All right. Now, once I put it in the calculator and I'm graphing it, I'm not seeing the whole graph, but I really don't care right now. I'm not worried about that. All I'm looking for is to actually find the rational zeros. So, like here, you might say, well, it looks like maybe at 2. And I start with the integer values. So maybe 2, 3, 4, 5, maybe 2 or 5. And so you start with an integer value, and then we do synthetic division. Okay, so let me just review synthetic division. We did that last week. So here we start with the coefficients, 2, -9, -18, 71, and -30. And so to see if 2 is a 0, we put 2 in the magic box and see if we get a remainder of 0, because that means it will divide in evenly. Okay? Now let's kind of switch up here so you can kind of see better. All right. So you bring down the first number, and 2 times 2 is 4, and then you add. -5 times 2 is -10, and then you add. -28 times 2 is -56, and then you add. 15 times 2 is 30, and you add and get 0. Okay? Now, that's very important. If we got a 0, then that means that 2 is a 0 of a function. When you plug it in, you would get 0. And so then what you're going to do is, so if you're trying to find all the zeros, we've got one of them now, and it's 2. Okay? All right, now, so how many of them are there? How many zeros are there going to be? What do you think? Is that going to be it? Well, it looks like the graph crosses 4 times. And it turns out whatever the highest exponent is, that's the maximum number that you could have. Okay? So we're going to see if we can find 2. All right, so we've got 1. All right, the next one here, it looks like it might cross at -3. So I'm going to put -3 in the magic box right here. I've got in green. Whoa, what just happened here? Okay, now this is important. Okay, instead of using the original numbers here from my original polynomial, I'm going to use these right here because there's one less of them, because I don't have to worry about the 0 remainder here. So I'm going to just use 2, -5, -28, and 15. So it's like I'm breaking down the polynomial. That's the whole idea. Okay? So using 2, -5, -28, and 15 with -3 in the magic box, I want you to see if -3 is or is not a 0 using synthetic division. Okay? So go ahead and do that right now. Okay, so is -3 a 0? Thumbs up for yes, thumbs down for no. Okay, I'm getting a lot of yeses. Let's see if the ayes have it. And you're right. It is a 0. Okay? So any questions to that point?
Whether you use the remainders from when you did the 2 for the synthetic division or the original numbers, will it be the same?
You'll get a 0, but the polynomial part, this part, will not be the same.
So is it incorrect to reuse the original numbers then?
Well, I'll tell you, it's not incorrect, but you don't want to use it. And for the next step, you'll see why. Because see now, this polynomial right here, okay, which represents 2x squared minus 11x plus 5. See now we can see what we're by not using the original each time, what we're doing is we're breaking down the polynomial and making it simpler. So now instead of to the 4th power, now it's just down to the 2nd power. And so even without the calculator, without synthetic division, once you get it down to 2, then you can use the quadratic formula. Okay? So you can always do that. So really that's kind of my goal, is to try to get it down to where it's to the 2nd degree. And then maybe I can factor it, okay? So then if I can factor it, come on, baby. Okay, look, I factored it. So now the last 2 are easy, because so I don't even have to use synthetic division 2 more times. I can just factor it. And so then once I've got it factored, and I set each factor equal to 0, then I have all 4 zeros. See, I have 1/2, 5, and then the 2 that I found earlier from synthetic division, 2 and -3. So those are my 4 zeros. And then this is the factorization. So I factored the last 2. And then if 2 is a 0, then the factor is x minus 2. If -3 is a 0, then the factor is x plus 3. So if the question says find the zeros or factor it, you do the same thing. You break it down, you find the zeros, look at the graph, look at the rational zero test, let that help you know where to go. And I'm going to show you some other little tricks along the way. Okay? But that's really the big show here for today, is finding those zeros. Okay? All right, let's go to another example. Okay, so next we're going to talk about Descartes' rule of signs. Now, again, the purpose of this is to let us know, to eliminate some of the choices so that we don't have a big long list of things to plug in for synthetic division. So to find the number of positive real zeros, determine the number of sign changes of f of x. Okay? So, like for example, see where this term is positive? This term is negative. This term is negative. So that means there's one sign change. So there would just be one positive real zero. So if we learn that, and I'll give you some more examples in a second, but like if we already found one positive, then we could eliminate all the other positives and not even have to look for those. And so it would save loads of time. Okay? To find the number of negative real zeros, you determine the number of sign changes for the f of negative x. Now, the tricky part, this actually applies to both of them. It's that you do the number of sign changes or less this number by a positive even integer. So like if you get 3 sign changes, you could have 3 or 1 zeros, or if you have 4 sign changes, you could have 4 or 2 or 0. And I'll explain why that is in just a minute, because that's kind of a weird little extra little caveat there. Okay. All right. So this is the deal. See, if let's say you have y cubed plus blah blah blah. Okay? The basic look of the cubic graph is like this black graph, right? But when you start adding and subtracting terms, you might very well shift this graph up. So it's possible that instead of having 1, 2, 3 zeros, you might only have one. Even though it's x cubed, you might only have one. So where did the other two go? Well, it's actually the other two zeros are complex solutions, okay? But they won't show up on the graph. And so you could be looking for them all day. And so it's helpful to know, okay, I've got that 1 0 and there's no more. Okay? It's nice to know that. All right. So it says, use Descartes' rule of signs to determine the number of positive and negative real zeros. Okay? All right. So imagine you're plugging in a positive number for x. Okay? So how many sign changes would there be in this polynomial? Okay, 1 or 2? Yeah, see, this is going to be positive, 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 and then negative. Okay? So then it only changes sign one time. Now, when the answer is 1 or 0, that's actually, you love that answer because that gives you the most information. Because this means there is one sign change. And so you don't have to worry about subtracting 2 from it until you get to 0 or 1. There's just one. And so if we find one positive real zero for that, we're done. We don't have to look for any more positive ones. There might be negative ones, okay? So now we're going to look for the negative ones. All right, so now to do the negative ones, we're going to plug in the f of negative x, okay? So write this down right here, this part in blue. And so you've got to figure out what the signs are for each of these. So like negative x to an even power, a negative times a negative is going to be positive. Whereas negative x to an odd power is going to be negative. Okay? So see if you can figure out the number of sign changes for the f of negative x. All right. So, Jill, let me help you through this because I know you kind of missed most of my explanation here. But when you raise negative x to the fourth, would that be positive or negative?
Positive.
Right. Okay, how about negative x to the third?
Negative.
And how about negative x squared?
Positive.
Times positive 3.
Positive.
Still positive. And then minus 1 is negative. Okay? So what we end up with is plus, minus, plus, minus. So that's 3 sign changes because plus to minus, that's 1. Minus plus, that's 2. Plus back to minus again, that's 3. 3 sign changes. Okay? So then what that means is that we're going to have 3 or 1 negative real zeros. So whatever number you get when you're doing these sign changes, you subtract 2 until you get to 0 or 1. So the first one we just had 1, so it's just 1 positive real zero. And the second one we had 3 or 1 negative real zeros. Okay? Now we're going to come back and actually find we're actually going to come back and find the zeros for this. Okay? But I'm going to go on to something else first. Okay, next are the bounds, finding the bounds of the zeros. Now this helps us to determine the window. If, like on our calculator, if we've got the window set up right, okay? So this is how you determine the bounds. If you divide a polynomial by x minus c using synthetic division, number 1, c is an upper bound if the last row has no negatives. So when you do synthetic division, your final row, if it has no negatives, then whatever number's in the magic box, that's an upper bound. What that means is you don't have to look past that number for more zeros. If you find out that 5 is an upper bound, you don't have to look past that. Okay? And so that can be very helpful to know that there's not one hidden from outside your window. All right, number 2, C is a lower bound if the last row alternates signs. And 0 could be counted as a positive or negative, whatever you need it to be. It's like a wild card. Okay? But you want the signs to alternate. So if you have a lower bound, it means that there are no zeros past that to the left. Okay? So see, if you correctly calculate your bounds, then you're not going to run into this situation where your calculator's showing you these, and then there's a fourth one outside your calculator window that you're not getting. Okay? So the bounds test can help you with that. Okay. Let's see. Okay, so we want to use synthetic division to determine if 2 is an upper bound and negative 4 is a lower bound. Okay, so I'll help you set up for 2. Okay, so we're going to test 2 as an upper bound. So you put 2 in the magic box, and then you set it up with the synthetic division. So what numbers are going to go across the top for your synthetic division?
3, negative 2, and
Don't you
a
have
couple
to put
of
the
zeros. And
Yes, very good, very good. You have to have your placeholders whenever you do synthetic division. So it's going to be 3, negative 2, couple of zeros, because there's no zero for 0x squared and 0x, and then a minus 6. Okay? So go ahead and do the synthetic division. And what we're looking for is no negatives on the bottom row. All right, so Avery, did you get no zero or no negatives, or did you get some negatives in that last row?
There is no negatives in the last row.
Okay, so if there are no negatives, okay, and look, I didn't even calculate that last number because I don't care. All I want, and so you can actually, at whatever point you realize that there's no negatives, you can just stop, put pluses or whatever, okay? So if there's no negatives in this last row, Avery, what does that mean?
It means that 2 is an upper bound.
Then 2 is an upper bound, so you don't have to look past 2 for any zeros. There are no zeros past 2. Okay? All right. All right, so now try to do the -4 as a lower bound. Whoops. So use the same numbers across the top. -4 is in the magic box. And now you want the signs to alternate if it's going to be a lower bound. So no negatives for an upper bound, alternating signs for a lower bound, but zeros are wild. All right, so Serena, when you've got it, let me know if the last row alternates signs or not.
Oh, they alternate.
They alternate. Let's see. They do. So we have positive, negative, and then I don't care what that is. I just know it's positive. Okay? So they do alternate signs. So Serena, what does that mean?
It's not an lower bound.
No, it is a lower bound. It is a lower bound. So -4 is a lower bound. Okay? -4 is a lower bound. So what that means is when we look at our calculator, if we set the window to go from -4 to 2, we should see everything that we need. Okay? There's not some hidden zero out there. Okay? We'll see everything we need. Okay, so what I would like you to do is on practice, well, okay. Let's okay, so use the results of the bounds test along with the rational zero theorem to find the rational zeros. Okay, and also use with your calculator's help. All right, so now what I want you to do though is we're going to change the equation. Okay. I'm changing this to match what we did in practice 1B. Or no, that's not 1B. I'm just changing this one. Let's see. No, that is 1B. Practice 2. So f of x equals x to the 4th plus x to the 3rd plus 3x squared minus 2. So I want you to use the results of the bounds test. So you could do the bounds if you want. We did the rational zero theorem for, we used Descartes' rule of signs on practice 2 for this one to tell how many we have. And so now what I'd like you to do is actually find the rational zeros, the actual zeros. Okay? Use your calculator to help. Use the bounds test, rational zero theorem, Descartes' rule of signs, whatever can help you. I want you to find the actual zeros to this. So, Cottrell, tell me what you're doing on this problem. Have you done any of the tests? Have you found any of the zeros? Where are you at? You put it in your calculator. What have you done?
Well, I tried to use the bounds, but I don't know how.
So in that case, I haven't given you any, so you can just pick whatever you want. Like, usually I do like 5 and -5 or something like that. Something that I would want to set my window to. Right? Now here's the weird thing about the bounds is that, like, I mean, you pick a number that's helpful to you. So look, like let's say you choose 10, and you find out that 10 is an upper bound. Well, let me go back. Let's say you pick 5, and you determine that 5 is an upper bound. Well, if the person sitting next to you chose 6, would 6 be an upper bound? If 5 is an upper bound? Yeah, because if there's no zeros past 5, there's not going to be any zeros past 6 or 7 or 10 or 100. So any number bigger than whatever works will also work. Does that make sense? So there's not just like one thing. Although like on a test or a quiz, usually I tell you what specific number to use to see if it's an upper bound or a lower bound. Okay? So you can pick what you want. All right, so I did 1
And down.
I got 1 is an upper bound, and -1 is a lower bound. Okay. So what that means is now again, if you pick 5 and -5, those would work. So you don't have to erase if you didn't use 1 and -1. I just use those to help because see when I graph it, okay. When I graphed it, I got this. So I got these 2 zeros that were sort of inside of -1 and 1, and I didn't know were there more? Okay, were there more? So that's why I picked those to be upper bound and lower bound tests. But again, 5 and -5 would work. Okay. All right. So did anybody find any of them? How many of them could there be?
2.
Well, there could be up to 4, but when I graph it, I only see 2. And then the fact that 1 and -1 are bounds for it, that means there's no more. So there's these 2 right here. Where are the other 2?
They're irrational.
They are irrational. Well,
imaginary.
actually, they're a magic complex. They're gonna have complex solutions. Okay.
I did the same thing as you, and
Uh-huh.
on my calculator, it looked like they fell right at 1/2, and I was like, oh, maybe it's 1/2 and -1/2. And I tested that with synthetic division, and it didn't give me a 0 at the end. So
Okay, so let me tell you how quickly in your brain, okay, without using the calculator, how you could know that 1/2 doesn't work. Okay, is the rational zero test says you take the factors of 1, which are 1 and 1, over the factors of 1, which are 1 and 1. So the only possible rational zeros are plus and minus 1. So 1/2 won't work. See, do you understand what I'm saying?
So the zeros have to be irrational then, because it's not hitting on the ones.
Correct. Yeah. So it's not hitting on the 1/2. It might be close. So how are we going to find them if they're irrational? That you can't even factor that. Well, what you're going to have to do if you can't factor, and here is you can't use the quadratic formula because it's not down to 2. These 2 you're going to have to find with second calc 0 on your calculator. Okay? So you'll have to do second calc 0. So look how close you were, Lauren. It's not at 0.5, but 0.514. So you're pretty dang close, but not quite there. So these you would have to do the decimal approximation with the calculator. Okay? And so, anybody have the other one?
Negative 0.486 after rounding.
I got negative 0.602.
Okay, can you walk through that then? I don't know why I'm wrong then.
That is kind of odd. But let's go through it. So what you're going to want to do is double check, make sure you keyed it in correctly. Or did you get the other 0 exactly on?
What'd you say?
Did you get the first 0 exactly right?
I didn't try the first 0 yet.
Oh, okay. See, because I would say most likely then you put it in the calculator wrong. That would be my guess. So just look. So it's x to the 4th plus x cubed plus 3x squared minus 1. So verify that you have that incorrectly. So just like this.
Okay, I got it. Found it.
Okay, so that was the mistake?
Yeah.
Okay. So, and that, it seems kind of silly, but that's really the most common mistake, is keying it in the calculator wrong. And then you do the second calc 0 to the left, to the right, and then guess, and you'll get those 2 zeros. So 0.514, negative 0.602. Okay. All right. Any questions on that? Okay. The last way to find zeros is kind of cool, and it's also using the calculator and what's called the intermediate value theorem. So the intermediate value theorem says that if f is a polynomial function such that the y values are not equal, so the f of a and the f of b, they're not horizontal from each other, okay, they're not equal, then in the interval a to b, if f changes signs from f of a to f of b, there is at least 1 0 on that interval, okay? So let me kind of explain to you. I think this picture helps. And this is kind of how what your calculator uses when it asks you to find the left bound and the right bound. Is it saying, okay, let's say for the left bound, it wants you to go to the left of the 0. And let's say if your function is increasing, to the left of the 0 means you're going to be negative. And then when you go past it, the right bound will be positive. Now, if your function is decreasing, it's the opposite. The left bound will be positive and the right bound will be negative. And so what that means is that the intermediate value theorem guarantees that if your function changes from negative to positive or positive to negative, it has to have a 0. It has to. Okay? All right? So, all right. So what we're going to do is to prove that there's a positive and a negative value, we're going to use the table. Okay? So use the table feature of the graphing utility to approximate the zeros of the function. Okay? Between 0 and 1. All right? So first thing is to put this into your y equals. Okay, so now we're going to do the table. We're using the table. So we're going to press second window to get table set. And so we want to show that there's a 0 between 0 and 1. So what we're going to do is start our table at 0 and then go in increments very small of like 0.1. Okay? And it's still going to be auto here. Okay? So go do your table start at 0, go in increments of 0.1. Okay, now press table. Okay, so let's move this. Okay, so looking at this table, where will there be a 0?
At 3.
At 3. No, just between 0 and 1. See, we want to, maybe I didn't have that originally. So I want just between 0 and 1. So here's 0, here's 1. So in these x values, oh, I see. No. Okay, the 0, when I asked for the 0, I understand why you said 3 now. I'm not asking for the f of 0. I'm asking for the 0 of the polynomial. So what's the x value that would give you a y value of 0?
Is it 0.8?
So not exactly at 0.8, but somewhere between 0.8 and 0.9. Okay? So why do I know that for sure?
Because there's a sign change.
Because there's a sign change. And that's what the intermediate value theorem says, is that there's a sign change from either plus to minus or minus to plus, there has to be a 0. Because the polynomial is what we call continuous. It doesn't just jump up. So it goes continuously from positive to negative or negative to positive. So somewhere between 0.8 and 0.9, not at those points, but somewhere in between, there would be a 0. Okay? So if this were a multiple choice test a multiple choice question on the test, then I would say something like, using the intermediate value theorem and this table, where is there a 0? And only one of the choices would be between 0.8 and 0.9. Okay? And so you would pick that one. Whichever one is between 0.8 and 0.9, that would be the answer here. Okay? So there's really nothing to calculate here. It's just that you have to look for wherever there's a sign change, you know there's a 0 in between. Okay? Any questions on that? Anything else on 4.3? Okay, so tomorrow I've got to send out the new guided notes for 4.4 and 4.5. So be looking for those, and then we'll kind of pick it up from there. Okay? All right, well, you guys have a great day, and we'll see you tomorrow.
Thanks, Mr. Strong.
You bet.
Hey, so Brother Strong, or
Yeah.
Brother Strong. So next week, there are basketball players that are going to be gone Monday, Tuesday, and Wednesday for a tournament.
Ooh.
Yeah. In
So
Tucson.
I'm trying to figure out something for Wednesday so that you know, where there might be some testing or quizzes or something, but maybe I can figure out a way that you don't have to come to school on Wednesday.
Okay.
But